Hello, everybody. I'm very excited to introduce Professor Terry Johnson. Most importantly, he taught us master students in the fall, a couple of us in the crowd. And he's going to talk to us today about field experiments and ML and aid, a huge breadth of knowledge, and an engaging professor, one of our favorites. So I'll let him take it from here.
Thank you very much. So I'm Terence Johnson. This is work with Molly Lipscomb, funded by the Gates Foundation. So market intermediation is a very appealing public policy tool, especially in developing countries. We often think they can kind of leapfrog over a lot of the problems that they face. And there are typically four problems that we think of. So externalities, that my actions affect other people in ways that I don't account for the costs or benefits of. Search frictions, markets are kind of scattered across different contexts, and it's very hard to find a good deal or find the right person. There's a lot of missed opportunities. Incomplete information means that two people on opposite sides of a transaction are asymmetrically informed. They have different intentions. They know different things about themselves and the other person. And then market power, that small players in the market can manipulate outcomes towards their advantage. So intermediation often appears to be a solution, especially as tech becomes more powerful, as we have more information about context, as we can deploy more complex solutions to problems. But there are challenges. So do we have the right data to predict out-of-sample behavior in novel situations? Right? How do we make sure that subsidy dollars and assistance get to the households who will actually use or who most need the assistance? And then how do we minimize procurement costs to maximize the impact of the budget? So what we're doing is trying to combine a set of skills across statistics, machine learning, mechanism design, and field experiments to try to build smart subsidies to maximize impact. And the context that we're thinking about, we're in Burkina Faso. We're interested in mechanical and manual desludging. So in peri-urban areas, they're highly dense. Households typically have a pit where human fecal sludge goes. The epidemiologists say shit. They're much more uninhibited, I'm going to call it human fecal sludge. Right? So you have the truck on the left. This is safe, but it's expensive. It's $30 to $50. There's a gas-powered pump. On the right, you wait until your neighbors are away, and then you crack the lid, and you literally empty the pit with a shovel and a trowel. The right, very hazardous to the person doing it, and also to the other people. Often the sludge doesn't get very far, right? So if you've emptied this pit out, you really have no safe place to deposit it. You're gonna take it somewhere in the neighborhood and kind of dump it out. This tends to increase disease burden, and that's one of our main concerns, actually. Right? So in terms of externalities, manual desludging has negative consequences for others besides the decision maker, especially children. So the leading cause of death of children under 5 in sub-Saharan Africa would be diarrhea. And lack of adequate sanitation is associated with that 10% of diarrheal disease. This is really interesting. The epidemiologists will have people put their hands in distilled water and then seal it up and send it off to the lab and build an understanding of how different vectors of disease are causing problems. Right? So we have externalities. We have our market power. The trucks exercise a lot of market power over households. I show up, I look at you, I assess your dwelling, I assess how you're dressed. And then if you appear to be richer, I'm gonna charge you higher prices. But even if you're not relatively well off, you're still gonna be paying $30 to $50. Okay? And then you might think, maybe it's okay, maybe the market still works fast enough, but the median time to get a tank emptied is about 12 days. This is a long time to not have a working toilet, right? And 20% take more than 10 days, right? So the trucks are typically not capacity constrained either. They could take on more work. The problem is no one wants these trucks near centers of social and economic activity. So you have to devote a lot of time to go and search for them, right? And then last, households and service providers have an incentive to understate or overstate their willingness to pay or cost. So they negotiate directly rather than through a market, right? It's like if you broke your arm and showed up at the hospital and that's the time that you're gonna negotiate your premium. Things are not good for you. They have you kind of at a severe disadvantage. If you say no, that means you're going back to the distribution. That could be another 12 days searching, right? So in a context like this, right, our motivation of kind of centralizing the market seems to be a good one. All right. But the policies that currently exist have some flaws. So the most common would be proxy means testing. Right? So the World Bank, the IMF, or a government comes in and says, OK, we're going to try to predict which households are below the poverty line from observable data, and we give them a coupon. And we say, you buy the service, we'll redeem the coupon, we'll give you some money back. So this excludes richer households who might pay money into the system. Right? And many households are too poor to utilize the coupon, and it goes unredeemed. And that's kind of the big problem. Right? So we can figure out relatively quickly who's relatively poor in this context, but how much aid we give them is also part of the intensity of the treatment. Right? And then with something like an auction, we actually did this in Senegal. The problem is you're essentially running a really good search service for people who would have bought it anyway. Right? So people love the idea that they can call a phone number, we run a spot auction over SMS text, and then we dispatch the cheapest truck to you. Except the people, that doesn't get the price down quite enough to increase the number of desledgings going to the relatively poorest households in the market. Right? So we call this a targeting problem. Subsidy money is not getting into the hands of the people most likely to change behavior. And we've known this for a really long time. And a lot of people have tried to work on solutions to it. So in principle, this seems like something we should be able to solve. Right? We can pick our prices to maximize the number of people who kind of subscribe to our service and then get the mechanical desledging. Plus, they might not subscribe, and they would buy from the market. And we might think that's a good thing. If you're relatively rich and you walk away from me and you buy the desledging anyway, I'm pretty happy about that. What I desperately want is to find the people who are not going to buy it without assistance, and then give them enough assistance to get them over the hurdle. Right? But we have our own budget constraint. I spent some time staring into the darkness, worrying about losing Gates money. That was probably silly. They have plenty of money, but governments don't. Right? A lot of low-capacity governments and organizations in developing countries, they have a limited budget. So the amount of money that we bring in on intermediating this service plus the subsidies has to be better than zero. So you look at this problem and you say, OK, well, let's just put hats on things, and we're done. The problem is that the data that we have, right? So we can reduce this to raw prediction and linear programming. But markets typically don't give us the data that we want for this kind of scenario. So if you look at a textbook, you see the picture on the left. Supply and demand, right? Everything's there, it's all pretty. What does the real world looks like? Chaos. I don't know where to draw the lines. I don't know what's supply and demand. And then below the market clearing price, we just have a big question mark, right? So the kind of like classic story about how markets work, they're good for aggregating certain kinds of information, but the scenarios that are outside what we observe in the market may be the ones we're interested in, right? So, like a simple kind of like machine learning 1 type picture, right? I have my household characteristics. Do they pick manual or mechanical desledging? And then we see prices. If I'm contemplating charging households $10,000, nothing here informs that. Right? The counterfactual question of what would happen if I charged one of these households $10,000 or even $8,000 is not really addressed. Prices typically range from $15,000 to $20,000. All right. So as we look at this world, we just don't have the right kind of data to address this problem, right? Even in a very data scarce environment like developing countries. So what we do is, like pack your bags, you're going to Ouagadougou. We run field experiments. I think this is an option that a lot of people could use in a lot of scenarios. There's a long tradition in environmental economics for valuing public goods, things like parks, experimental economics, market design, right? What's an incentive-compatible way to say, hey, at what price are you willing to switch? That's what I really want. Now, A/B testing is great, but it's very local. It can tell me the consequences of moving my policy lever back and forth, but it doesn't tell me why, and it doesn't tell me what would be the price at which you would switch? It only tells me at this price, if I move it to plus or minus $1, would you be willing to make the trade-off or not? Right? So an informationally more efficient way to go about doing it might be to elicit that information. So here's kind of the preview of what we did and our kind of main results. So we gathered data to estimate demand systems through these demand elicitation experiments and surveys. Right? So we have an initial sample that allows us to train our predictions and figure out how we want to solve that linear programming problem. What kinds of prices are going to go to which kinds of households. Right? So step 2 is we go ahead and we solve it. So we have about $3 per household in terms of our budget constraint. So that's 12% of the average cost of a desludging, a mechanical one. And then we go back and we implement the new pricing rule and we measure the economic and health impact of the treatment group relative to a control group. So you can run the experiments. You can go back and do it. You can do the RCT. I think a lot of times people say, we're not actually going to test things. You really should, especially in contexts like health or contexts where these are going to have potentially large consequences for people. So overall, we increase utilization of mechanical desludging 6.5 percentage points relative to a control group. And if we look at the group that was most heavily subsidized, the group that we're kind of most interested in targeting, that's an 11 percentage point increase. So the average treatment effect is essentially concentrated in the people that we really wanted to help. Diarrhea incidence among children decreases 5.5 percentage points in the most heavily subsidized group relative to control. And we lost $5, right? Which I just feel lucky about. I'm just grateful. Because we engage with thousands of households. Right? So do you have any questions before we move on? Yeah.
You missed $5 overall or $5 per household?
Overall.
Okay.
It's like an expensive beer. Yeah.
The subsidies, are those vouchers or just money? Like, how's that?
We handle it through a call center.
Okay.
So at the time that the household wants to get the desludging, they call us. We put a sticker on their toilet with the phone number.
Cool.
Yeah. And they just call us, and we look up their household ID, and then we arrange the desludging at a lower price. A part that, I only like 30 minutes, so I'm trying to focus on the demand side, but on the supply side, we're also running auctions and trying to drive prices down so that we can make the money go further. So we dispatch a desludger, and they take care of things. Yeah.
So that wasn't clear earlier. You're issuing a coupon that reduces the cost, doesn't eliminate the cost like that.
Yeah, it's not going to zero. They're still going to have to pay something, but we kind of fix the price. So we say it's going to be $15,000, $17,000, $20,000, or 10. Right? So the 10 is the very low cost group. Okay, cool. So that's kind of the overview, kind of like the ideas, what's interesting. So how do we get the right data? So we put Open Data Kit on Android tablets. We hire a bunch of people. The enumerators proceed to GPS coordinates, and they interview households. So this is our first group. This is kind of like our pilot where we're going to learn what we need. So the enumerators survey about the most recent desludging experiences, observable household characteristics, which we think this is important. It's got to be things that either the government or a nonprofit could see. So we're using dwelling build quality, owner rent, electricity and water bill, how big is the pit, does the compound have a wall, how many households are in the compound, how far is the pit from the road because that affects the price of the gas for pumping the sludge out, how many trips were needed in the last desludging, and then an approximate guess of household size. Yeah. So one of the biggest problems, like a lot of people come in and they're like, we're going to solve this, except information is relatively scarce. So you have to gather it in a really low cost way. Right? And then they play a demand elicitation game. This is the part that's interesting. There's a field. I think everybody should know about this field, especially in machine learning. It's called mechanism design. It's basically the inverse of game theory. In game theory, you say, OK, people have this scenario. How are they going to behave? What predictions do we make? And if you flip it around, you could say, how do we get people to behave in a certain way, given their information, preferences, and constraints? So there's two classic ways to elicit honest valuations. The first would be the second price auction. Right? So we say, OK, all of the participants write down a bid, highest bidder wins, and they pay the second highest bid. I see some people who look like I have assaulted them with a lemon. You don't like that. What don't you like about it?
Why does it work?
Why does it work? So imagine the English auction. I have a lovely thing here. Got my tag. Look at it. It's got this like shiny thing. I say, OK, humans, I'm going to start with a really low price, a penny. Please raise your hand if you'd like to buy at a penny. And as I start raising the price, what you see is people drop out when the current clock price exceeds their value. And what happens is the final person drops out when we have just about reached their value, and the winner is going to pay the second highest bid. Do we agree? So the winner has no incentive to reduce their bid, right? The one that they had in their head, because they never get kind of activated. The price never reaches the point at which they would drop out. Right? So this game kind of replicates the English auction, but it does it in a sealed bid way. So if you were to go above your value, that just exposes you to risk. Because if you win at a price higher than your value, you regret it. And then if you drop your bid below your true value, someone else might bid in between and deprive you of the value of the item that you could have won and experienced some joy. Now that's a weakly dominant strategy, to be honest. I love running this with MBA students. Because you have two people, often, who have the idea, I'm going to bid $1 million for that pencil. And they find out very quickly why it's a weakly dominant strategy. You can win at any cost, but you'll have to pay it. So if you're honest, you face no risk. Right? If you're dishonest, you face a risk of overpaying when you win or losing out on winning when it was valuable for you. So we'll play this game 5 or 6 times with the household. They'll get a sense of like why we would say that this is true. And we say, you can do whatever you want. You know, it's your life. Right? We play the game and we elicit a value at which they're willing to switch. So that's how we get information about how households would actually like to engage with our system. Where is it that they would switch and actually buy the desludging versus drop out and not participate? There's another way to do that called Becker, de Groot, Marshak, which is kind of like the same idea. And then this is a whole field. Like you can spend a significant amount of time studying how people think about this. Okay. So this is how we do field experiments to elicit that piece of information. And then we can figure out how people would behave. So we can take a look at a household, we can look at their characteristics. Are they going to buy in the absence of our intervention or not? And then conditional on whether or not we think they're selecting into purchasing or not, we can think about making a price quote that competes with the market, or it ends up under their willingness to pay and switches them from manual to mechanical. So this is the part where we just put hats on things. We just have a trivariate normal type model. We include those variables that we looked at before. We do some regularization. Boom, we're ready to go. So we can come up with a household level demand curve. Right? So what's the probability a household is going to accept? Most drop out at 20,000. Some are in at 17.5. Right? We can see who wants to buy from us. And then we can see how those households actually are going to behave in the market. Who's actually going to buy the mechanical desludging? All right. What I think is interesting is that even moments that we didn't target have a pattern. The people that we quote 20,000 versus 17.5 versus 15,000 versus 10,000, you see the right monotonicity pattern. Right? So example, for cars, the people that we're quoting the lowest price to typically don't have a car. The people that we're quoting 20,000 to typically have 1.5 cars. That half a car is really not super helpful, but, and then in the middle you've got your 30% and 60%. So across these things that we didn't target, air conditioner, last used manual, number of refrigerators, it has the right pattern. We're targeting people who are relatively rich versus relatively poor. Initially, we allowed the linear programming problem to consider prices below 10,000, but it just didn't think they were optimal. We couldn't flip any households that way. So there are prices that got removed by just raw optimization. So once we have our rule, we program those tablets again, and we go back and we get a new set of about 3,000 households. Half are offered our treatment, our kind of adapted price. The other half are not. They're our control group. But we know which price we would have offered each household in the control group, so we can compare them. So we can say your household who would have received 10,000, we can compare the people who did get 10 versus the people who would have gotten 10, and we can look at treatment effects across the kind of population. So here are the results of the RCT. When we pool everything, the average market share in the control group is 84% get mechanical. So the average treatment effect is 6.5 points. But then when we break it out by the individual price groups, you can see there's almost no way that we could have increased the 20K group. They almost all get mechanical desludging anyway. As we go to 17.5, utilization drops 10%. We don't have a statistically significant effect there. When we go down to 15, right, it goes down another 5 points. But all of that treatment effect is concentrated in the 10K group, for whom the average market share of mechanical is about 60%. So we're getting them from 60 to 70%, which is, in the context of what's going on, relatively significant. So in that 10K group, we also ask about health effects, right? There's a 5 percentage point decrease in the probability of reported diarrheal case in the 10K group. So this is consistent with epidemiological research, right? Basically, like if you think about those 12 days when you don't have a toilet, you're exposed to a lot of problems. Like people are going to be open defecating, they're going to be going in public toilets that are perhaps less sanitary than a home toilet. People who are younger have more, challenges here. They maybe don't have work, or school is not a great place for them to go to the toilet. Right? So the evidence is consistent with what happens when you build a new toilet or restore access to a toilet. That's what we. Right? And then if you look at kind of within cluster, if we're treating a lot of households with the 10K price, we're getting even more of an effect. So that's where these positive spillovers, we can find evidence for it. And then depending how you do the accounting, we either earned 18 cents or lost $5. Because there are different ways that you could kind of figure out the accounting, which is surprising. I thought this was going to be worse. One of the things that we look at in the paper is if you change the information set, you constrain information, we rerun the whole thing, and we predict what would have happened counterfactually with a different pricing rule. What tends to happen is the treatment effect remains high, but the budget balance falls apart. So we're still targeting households we can flip, but we're making more of the kinds of errors where we're giving money away and not covering it when people actually make their choices. So ex ante, without information, we tend to just lose more money, which is an interesting. I didn't expect that. I don't know what you would have expected, but okay. And going back to that kind of initial question, what if we had done proxy means testing or a fixed price, that's centralized market, or we did auctions where we just subsidized the clearing price? You can kind of see the mechanics of what happens. So with proxy means testing, right, the people that we refuse to give a coupon to, that's that spike at 0. They're just kind of pushed out of participation. And then we're subsidizing relatively poor households about 2.5%, right? For the auction with the subsidy, we don't have that spike. Everybody kind of gets to participate, but we have an even lower subsidization rate. What we're doing is saying, hey, look, those 10,000 people, we're going to dump enough aid on them to get them over the hurdle. Right? We're getting subsidization rates that are twice the PMT and auction. And then the relatively richer households are actually going to be paying into the system and relaxing our budget constraint. Right? So when you combine all of this, you end up with a system where you're cross-subsidizing people, and the 17, 5, and 20 households, they're actually happy because they would be paying more to a desludger. We're buying in bulk, and that's how we're getting prices that are relatively low compared to the market. Right? So that's the basic idea. So if you haven't looked at the world of mechanism design, algorithmic mechanism design is a super underutilized set of ideas in the space. Some people you could look up are Noam Nissen or Tim Roughgarden or David Parks. So things like designing auctions, designing real-time allocation services. It's a really cool set of ideas. We have other projects. If you are entertained by our misadventures in poop economics, Planet Money has a podcast called Poop Cartel about what we did in Senegal. And then a thing, that, all causal inference problems are essentially missing data problems, is a useful thing to remember. So whenever you're asking, what if I change the system? How is it going to impact users? How is it going to impact the people participating? The real problem is that you don't have the right data to just go look it up with KNN or something. That's why we're relying on the models. But sometimes the models can't handle that entire job, and we need more data. So it's worth thinking about what are cheap and effective ways to gather the data we do need to make the right decisions. Okay, yeah.
All right, great. For questions, let's use the microphone because it's recorded. So just want to pick up all the audio.
You showed the other correlated characteristics of the households,
air conditioners and number of cars and stuff that seem to be very correctly, positively correlated with the characteristics that you had measured.
Yeah.
Those seem like other ones that you could passively measure. Like
Yeah.
you could just walk around and say, oh, they've got 2 cars in their driveway. Awesome.
Yeah.
Right? Without even interviewing the family. Maybe.
Absolutely. Yeah. So we were, we wanted to be relatively conservative about what we did, and we only got 1 shot. So what we didn't want to do is pick something like number of air conditioners and then have it kind of go sideways on us. So we gathered the data, but then we didn't put it in the model because we also think like if you did this at scale, and people knew like these needs assessment people are coming by, hide your air conditioners, they absolutely would. So things like the dwelling quality. Yeah, so it's like, I think that's interesting though. Like what's the balance, like what's like hard observable, what's totally unobservable, and then there's a continuum, right? And in that continuum, you know, there are choices to be made. It's kind of an interesting question. And it gets to a lot of the things that we hear about, like how do you, so your bot shows up at my website, how do I conclude what your intentions are, right? And the minute you say, I'm gonna look at how many cars you have,
Drive your car.
move your car to your neighbor's place or something. But that's a really good point, yeah.
Yeah, following up on that question, is there any data in your study that tries to capture kind of the contemporaneous kind of word of mouth? Because I imagine a community like this, you know, neighbors are saying, hey, someone's coming by my house, they're giving away coupons for, mechanical sludge removal. Does that data show up? Did you have any mechanism to capture that type of interaction during this study?
So this kind of thing, I think they don't, you know, we have like a team of enumerators and they just kind of wander around with tablets and they knock on doors. So I don't think the word of mouth becomes like a problem that quickly in this one. But in Senegal, part of the problem is the idea of just-in-time auctions run by SMS text. The government really liked it, so they scaled it up. So then when we were trying to think about these kinds of like causal inference questions of treatment versus control, we had to think about things like, well, there were ads on the radio. So like when did the radio ads hit and how did they kind of like spike retrieval and stuff? So one of our co-authors worked a lot on that, thinking about how diffusion of information and release of information led to utilization or not. Yeah.
I've got one.
Yeah.
So you mentioned like the government scaling it up. How does a commercial versus government waste retrieval or like price fixing by the government, like how would that influence the way that you're approaching subsidies for people?
Yeah. So we thought of it primarily as they have access to things like electricity and water bill. So we had partners in the local governments for these studies. We had partners in local nonprofits. So we all kind of collaborated. And that's what led to our kind of a bunch of these choices. But when you pivot it over to the government, part of the question is like, why doesn't the government just buy these trucks? Yeah, that is exactly the gesture that many people have made. And a little bit of it is they don't have the capacity and they don't think that this problem is forever. So they're like, well, we're just gonna build a sewer network. We're gonna demolish these peri-urban areas. We're gonna build townhomes and everybody's gonna be happy. So there's a little bit of a tension between, you know, the suffering that's occurring now seems very salient to a lot of people, but also the government is extremely forward-looking. So that's why this intermediation becomes kind of attractive. It's like they could be doing this, and be involved, but not necessarily committing huge investments into trucks or the sewer network. And that's what ends up happening in Senegal is there's kind of like a privatization. Here, it kind of got handed off to a Dutch nonprofit, and they worked with the government, and they kept working. But in Senegal, there's a much more kind of interesting kind of partnership between the Association of Desludgers, the local government, and the truckers themselves, and a company that kind of manages the auctions. Yeah.
All right. Thanks so much.
Yeah.